First thing I'm asking you to sign. I will not knowingly engage in engage in dishonorable behavior, cheat, steal, or lie, and commit any act of plagiarism during this academic work, course, or endeavor. Evaluations will be completed by myself without the assistance from fellow students. If I observe an act which I believe violates this honor code, I may, it's up to you, in my discretion, report this to the appropriate personnel. Okay, basically, I'm telling you, do your own work. Okay, and if you're signing this, okay, you're telling me that's what you're going to do. I have no way of verifying one way or another. Okay, I'm not going to have you take your classes on Google Meet where I'm sitting there watching you. Okay, but this is on you at this point. If you choose to do something that's against this, you're telling me right now that you're not going to. Which means that's your word, and that's on you, not on me. Okay, I feel I don't have to worry about this, but I need to throw it out there just to make sure that we understand the expectations of we're remote learning. We're going to go through what we normally need to go through. Okay, so you need to make sure that you do what's right by you ethically in regards to your coursework. Okay, it's not an ideal situation. Obviously, this is not an ideal situation, but it is what it is, and we make the best of the situation as we move forward. The true test, once again, I tell my other classes this, the true test. And this is not just on this class, it's in life. Whatever act that you have decided to do, would it be okay if that act, whatever it is the headlines of the Down Gazette or the Daily Record? If you say, I don't have a problem with this being the headlines of the Daily Record or the Down Gazette down here, go ahead. If you sit there and go, yeah, I'm not quite sure about that one, maybe you should think second about doing it then. So that is the litmus test that you have, that little test that you can have in your brain when you're making a decision, yes or no, on whatever you're going to do, whatever it is. Is it okay if this is the headlines of the newspaper? That's just a life lesson as you go through your entire life. Not just, like I said, not just this class. It's anything that you do in life. If you're making a decision that you sit there and go, I don't know if I would like that to be a headline or not, maybe you should think second about doing it then. Okay, you still may do it, but at least you think about it a little bit. Any questions about that? Okay, once again, I have no way of proving or disproving if something did occur. No way of doing that, unless it is obvious. But if you're telling me that you're okay with doing this, and you're signing a piece of paper, yeah, your word is, I'm accepting your word that this is going to happen. Questions? All right, I'll collect those. Okay, the second thing I've learned as I've gone through these processes now, we've all gone through the processes for 10 months or 9 months or whatever it's been. The common, I don't know what to say, complaint, but common thing that comes to me is, Mr. Gregory, my printer is out of ink, my printer's not working, I have printer issues. So, the second packet of information I gave you, that's paper close together. That is all your notes, homework, worksheets, and review sheets for the rest of the year. So, you do not have to worry about printing anything except for a quiz. That saves on you and your family's budget on computer ink and printer ink. I get it. I understand. Those are things I never really thought of until I was going through this in the springtime, and people are starting to have issues with that. I'm thinking, okay, now how can we do this a little bit differently? Well, since we're doing in masses now, I thought I'm just going to print all my notes, all the blank sheets that you get. I printed them all yesterday, put them together, alphabetically ordered for the rest of the year. Okay, so all you have to do is take the next one in line. If I miss something, I'll have to post that and you're going to have to print it at that point. But for the most part, this should help you in regards to not having to print stuff. Okay, our notes, okay, in a matter of 24 hours, I figured out how to screencastify, or I'm sorry, Google Meet, Google Present, and also Castify that. Okay, so that I can now lock it into a YouTube video. I don't have to no longer have a tripod and a YouTube and an iPad here anymore. Okay, everything will be Google Meet. I will go into present mode, and I will screencastify that present mode, which means I can capture it then and post it on our Google Classroom. Okay, so once again, I'm trying to make this as easy and painless as possible for you. Okay, to make it so we can get through the rest of the year. We have stuff that we have to cover, and we are going to cover it. Okay, I don't see this as a break at all. If I need to have a class on Friday, I will call a class on Friday. Hopefully, I can just provide. Friday is not a day off. Friday, I just may present for 10 minutes and give you information and work to work on. Okay, and if I don't even need to have a Google Meet, I won't do a Google Meet. I will just present stuff on Friday or give stuff to you to work on Friday and over the weekend. So don't sit there and say, Friday, I'm off. Don't have to do anything. No, Friday's not a day off. Friday, there will still be material there for you to be able to work through. My goal, once again, is to hopefully to get through the end of the coursework here by Christmas time, so we can take a final right before Christmas, and I don't have to wait till 2 weeks after. You don't have to wait till 2 weeks after to get a final in. I don't know if I'm going to be able to accomplish that or not now. If I can, I'm going to, because I know 2 weeks off of doing anything mathematically is not a good thing coming back the other direction and having to take a final when we come back from Christmas break. So I'm trying to make it easier for you to remember and recall stuff. Questions you have? Okay, we meet Tuesday, Thursdays. Your times have been given to you. I need to see a face. And I need to take attendance. You need to stick around for once again, I will be in present mode. So we will be live. And at that point, after being live, I will capture it. And if something comes up that you can't be live that day, which I understand, something could occur, it will be captured that you can review it at your leisure and at your time at that point. Please make sure after I take attendance, I may say good morning to you. I'll take attendance. Please turn off your camera. Please turn off your mic. Don't need to know that Rover needs to go outside and he's scratching at the door. Okay, or the kid, or Felix the cat needs a treat. Okay, I don't need that. Or a bird is singing in the background. I don't need that. Okay, nobody else wants to hear it. So turn off your mic. Okay, turn off your camera, because I don't want signs being posted from one to the other saying this is stupid, this is idiotic. Okay. What is it? I don't need signs being posted behind my back. All right. So turn your camera off also. I may be old. I may not know technology, but I know a lot of tricks of the trade. I understand being in your seat, because that would be me. Given the opportunity, that would be me. I think through a lot of things, and I've experienced a lot of things, and unfortunately my kids they're the ones that get to experience of not being able to do this and do this and do this when they were in high school. Why? Because I remember what I was in high school. And not that I partake, but I saw my friends. Okay, so questions that you have. I've tried to, once again, make this as easy and seamless as possible for you. But once again, you need to be able to come back my direction and be able to accomplish things coming back in my direction too. Okay, being that we're not in a remote setting does not mean we don't have school. I think you've been around me long enough to understand my expectations in the classroom. They don't change because we've gone remote. My expectations are going to be maintained. Whether they're accomplished or not, that's a different story. My expectations aren't changing though. Okay, on page homework for today, page 201, page 202, you had some inverse and arc trig functions. Once again, when you're dealing with inverse trig functions, there's problems that we run into with inverse trig functions because the nomenclature, you have tangents to the -1 power, you have sine to the -1 power, that means inverse tangent, but also algebraically that means 1 over. That means the reciprocator base. So we changed the inverse sine, inverse cosine to arc sine, arc cosine, arc tangent. Okay, it means the same thing. And as you went through your problems for the day, you had some of them were inverse trigs and some of them were arc trigs. Okay, because they mean the exact same thing. Solutions though need to be in terms of pi and in radian form. But as I said, as we talked about on Monday, bend the rules a little bit. Okay, put it in the degree mode. Do everything in degree mode, and then change your degrees into radians. Okay, change the degrees into radians. Make it simple. Solutions need to be in radical, or any radicals need to be in radical form. I don't want decimals there. Get us in radical form. The only one that you have to worry about, once again, is if you're doing the inverse cotangent or arc cotangent of a negative. Okay, your calculator will give us the principal value every time with your angles. Okay, your calculator will do that, except for the arc cotangent or inverse cotangent of a negative. Then you have to add 180 to it. Okay, so you have to know the difference between that. If I take the arctangent of -1, I get -45, which is negative pi over 4. If I take the arc cotangent of -1, if you remember what we did, this turns into arc tangent of 1 over -1. Which turns into the arctangent of -1 again, which is -45. But the original problem wants us to deal with the arc cotangent. Arc cotangent, the principal value is not between -90 and 90. The arc tangent is between -90 and 90. Arc cotangent is between 0 and 180. So we add 180 to this to give us a 135. Or 3 pi over 4. Okay, so that's the only time that you have to worry about that. If I gave you a problem with the arctangent of -1, solution is -45, pi over 4, I'm done. QED. Okay, but if you do the inverse cotangent or arc cotangent of the -1, then you have to add your value to it, add 180 to it. Any questions you have on any of the problems? Again, you add multiples of 3. Go 1, 2, and 2. Work yourself inside out. Find the value inside the parenthesis first, then go to the outside one, just like you normally would do with the parentheses. All right, please keep up with the material. This, once again, if you need a grade, this is it right here. The next 3 quizzes, if you need grades, We have 3 quizzes left. If you need grades in this class to pick your grade up because of the aftermath of trig identities and trig formulas. Okay, the lowest quiz grade gets dropped in this class every 9 weeks. So I dropped that lowest quiz grade. So one of those goes bye-bye, but you have enough points here that you can make up. If you had a C on your other one, you have 2 C's, you can drop one of those. The other one can get picked up real quickly by getting some good grades on these quizzes. But you have to do the work to get to that point. Today, what we're going to talk about is the law of cosines. So this is something that's a little bit more familiar to you. You did this over with Dr. Clark a long time ago over in geometry. Okay, we did law of cosines. You should have done law of cosines. Okay, you should have done law of cosines. But we'll get a little bit more in depth with respect to law of cosines here. Before we get into law of cosines, we're just going to go through triangle properties. Properties of triangles. If you have the angle sum of a triangle, you add up all the angles of a triangle. They add up to what? Grace, what do they add up to? Triangle. Triangle. Add up to how many degrees? 180 degrees. That's an easy one. 180 degrees. At least in Euclid's geometry. In Euclid's geometry, they add up to 180 degrees. And people that don't quite believe in Euclid, okay, it's the angle sum of a triangle is less than 180 degrees. What is it? I don't know, it's just less than 180. Okay, the equator, is it a line? Is the equator a line? What's the equator? Well, they say it's a line. Northern hemisphere, southern hemisphere, equator, it's a line, right? Or is it a line? It's a circle. It goes around the world. So they say it's a line, but really it's not a line. If you travel 100 miles due south, then go 100 miles due west, and then go into 100 miles due north. You're going south 100 miles, west 100 miles, north 100 miles. South, here, here. And you end up at the same spot. You start where you ended, or you end where you started. Where are you at? You go south 100 miles, west 100 miles, north 100 miles, straight, straight, straight. But you end up where you started. Where are you at? Well, I just went 3 directions there. That should be a triangle, right? Oh, not a triangle. And I'm saying it's ending up the same spot. North Pole. You're at the North Pole. You're going 100 miles due south, which means you're going over the hill a little bit. Then you're going due west. Then you're going due north, and you're coming back up. Because the North Pole, I can run my compass. Okay, my compass says I'm going due south, 100 miles. Okay, then I go 100 miles due west. Then I go 100 miles due north. Well, the North Pole takes us back, it anchors our directions. So you're dealing with being at the North Pole. Very good. But I just gave you 3 directions, and we ended up where we started. So we went, let's see, this way, that way. We're back up there at the North Pole. We're seeing Santa up there. We just created a triangle. Are those straight lines? That's what the non-Euclid believers say. Non-Euclid believers in geometry eliminates the idea of straightness. Okay? I'm walking here. Did I just walk a straight line? Did I walk a straight line? There you go. I'm walking right along that line. Did I walk a straight line? Yes. Or is it curved? Is it curved? You're going down 30. That's a straight road. Okay, in a section of 30, you're just going, it's straight. I just keep going straight. But till I go straight. If I fly from Cleveland to Chicago, do I go in a straight line? No, I have to go a little bit of an arc there. If I go in a straight line, I'm going to end up out of the atmosphere. Because I go in a straight line, it's just going to keep going up. Well, the Earth is curving. I'm going to be up in the atmosphere at that point. So that's what non-Euclid believers believe in. If you're related to the science world, Sir Fig of Isaac Newton believed in Euclid. Everything is a straight line. This object fell in a straight line. Okay? You have the non-Euclid believers who goes into Einstein's idea of everything is moved in a curved path. Okay? The non-Euclid believers go into Einstein's idea of relativity and gravity, and Euclid's believers go into Sir Fig of Isaac Newton's idea of physics. Everything is in a straight line, or could be reduced to a straight line. When you get close to the Earth, Einstein's idea reverts back to Sir Fig of Isaac Newton. But if you're out in the outer space, it doesn't work. Anyways, let's see. The measure of an angle must be opposite. The small measure of an angle must be opposite the shortest side. Here's your math theory of the day. I had to take one geometry class in college. The first 5 weeks of this, 6 weeks of this was all Euclid's idea of geometry. What you learned in high school could handle that. The last 10 weeks, it was all non-Euclid stuff. So you had to eliminate straight lines from everything that you did. Straight lines. And relearn geometry and prove things without straight lines. That was tough. The largest angle must be opposite the longest side. So the smallest angles across from the smallest side, the biggest angles across from the biggest side. When any two sides of a triangle are added together, when you add any two sides of the triangle together, must be greater than the third side. Must be greater than the third side. When the lengths of any two sides of a triangle are added together, it must be greater than the third side. If one side's 3, the other side is 5, this third side can't be 9. These are all properties of triangles that will be useful because we're going to be dealing with triangles. For any right triangle, we have our good old buddy Pythagoras. He never goes away. He'll always be there. Our good old buddy Pythagoras. Leg squared plus leg squared equals the hypotenuse squared. For any right triangle, or for any triangle, vertices are labeled with capital letters, and the sides opposite are labeled with lowercase of the opposite vertex. If this is big A, this is little a, opposite side. If this is big B, this is little b. This is big C, this is little c. We have two lines. These sides are made from line segments, which are parts of lines. Two lines are intersecting. They intersect at a point. And that point is always labeled with a capital letter. That's what you learned back in Dr. Clark's geometry. Points for capital letters. It's easier to get the side opposite just being the lowercase. Well, we've gone through right triangle ideas. If I want to find little b, here, and I know this angle, big B, is 73. First off, which trig ratio relates 73 to little b and this side here? Well, these two sides. This angle to this side to this side. Tangent. So we have the tangent of 73 degrees is equal to b over 10. We can multiply both sides by 10 by 10. So we have b is equal to 10 times the tangent of 73 degrees. Okay, right triangles A. This is what we did at the beginning of trig class. Okay, solved right triangles. But we had to make sure when we used trig ratios that we had a right angle in there. And we do. So we have 10 tangent of 73 degrees. What we come up with? Anybody? What we get? 32.7. Thank you. So the length of this is 32.7. We had to have a right triangle to be able to use sine, cosine, tangent. Problem we run into, everything in the world is not a right triangle. How do we deal with a triangle that's not a right triangle? Well, how we deal with a triangle that's not a right triangle? We draw an auxiliary line in there that makes us a right triangle. We have big A, the side opposite of that is little a. We have big B, the side opposite of that is little b. Big C is here, the side opposite of that is little c. This is a height or an altitude. Now, I've created two right triangles here. Right triangle number 1, right triangle number 2. I need to throw in one other value in here. I have this as h, my height. If I make this length of this right triangle here, from here to here, length x. If this length is x here, the entire length is c. What is the length of this segment right here? The entire length is c. This is x. This length here would be what? Okay. C minus x. C minus x. In right triangle 1, using our good old buddy Pythagoras in right triangle number 1. Isaac Phillips, what would our good old buddy Pythagoras say in right triangle 1? I'll bring him along just to help us a little bit.
Are you asking?
Yes. Isaac, what would our good old buddy Pythagoras say in right triangle number 1? I have these sides here. I have this triangle right here. What would our good old buddy Pythagoras say? I know. What's my variables? Use my variables. X squared plus
X squared plus h squared
equals b squared. All right? Very simple. Right triangle number 2. What would our good old buddy Pythagoras say in right triangle number 2 here? Molly? I'm just looking at this triangle here.
It would be h squared plus c minus x squared equals b squared.
All right? That's what you'd say in triangle number 2. Now we're going to use some algebraic skill. The c minus x quantity squared. C minus x times c minus x. Using our FOIL, this comes down to c squared minus 2cx plus x squared. Okay, all I'm doing is I'm FOILing this out. Okay, that's an algebraic skill. So we're left with h squared plus c squared minus 2cx plus x squared is equal to a squared. If x squared plus h squared is equal to b squared, what would x or h squared equal? If I solve for h squared, what would h squared equal? Nathan?
B squared minus x squared.
B squared minus x squared. So we're going to make a substitution. This h squared is the same as this h squared. So using our substitution principle, we have b squared minus x squared plus c squared minus 2cx plus x squared is equal to a squared. Well, what so happens nicely, we have a negative x squared here, and we have a positive x squared here. They go bye-bye. The x squareds, they move to Texas. So they're gone. We only z out x's, because if you x out an x, you still have an x. So you have to z out the x's. So I'm going to flip this around. I'm going to put the a squared first. So we have a squared is equal to b squared plus c squared minus 2cx. Now what we've done nicely here is we've eliminated all the c's and x's, because what we want to create is we want to create a relationship between lengths of sides of the triangle and measures of angles of the triangle. That's what we want to create. Just like we have a squared plus b squared equals c squared. We have Pythagorean theorem. I want to create something when it's not a right triangle. Well, the only thing that we have here is this x. And if I take a look at triangle number 1, triangle number 1, we have h here, we have x here, we have b here, and we have a here. Which trig ratio relates this angle A to the x and the b? Sean, which trig ratio relates this angle A to x and b?
Sine.
Sine. Because sine is defined to us as what?
Opposite over hypotenuse.
So this is opposite over hypotenuse of A.
Or cosine.
Cosine? Because cosine is defined to us as what?
Adjacent over hypotenuse.
Is this adjacent hypotenuse? Yeah, there we go. So we have the cosine of angle A is equal to x over b, which by multiplying both sides by b, these cancel. X is equal to b cosine of angle A. So making one last substitution here, we're left with a squared is equal to b squared plus c squared minus 2c b cosine of angle A. This here is the law of cosines. Every triangle has 3 law of cosines equations. Let's take a look at the characteristics of the law of cosines equation. It looks like Pythagorean theorem to begin with. A squared equals b squared plus c squared. That's good old buddy Pythagoras. Minus 2. These two, b and c, are right here. Cosine of angle A. Well, that's big A. This is the little a out front. So if we recopy a second one or make a second one here, b squared would equal the other two sides being squared. A squared plus c squared. Minus 2. Now I recopy these, A and C. Cosine, this is little b. Angle B out front, and back. C squared equals. Are the two sides being squared? minus 2, those same two sides here. Cosine of little b, big B, little c, big C. So we have, and it doesn't matter if you write a squared plus b squared or b squared plus a squared, it does not matter. Minus 2 AB cosine of angle C. Very quickly, triangle rat. All my triangles are going to pretty much look the same. I don't anatomically make them correct. And I typically, and this is just me, you do your own thing, I typically start with my first letter on the top, and then I go left to right on my radio dial. If you do it differently, that is fine. Side opposite, little a, little t, and little r. R is 10, little t is 7, angle A is 71. Now when dealing with these, you always want to write out your law of cosines equation first without numbers. If I started out with a squared, my other two sides being squared, Pythagorean theorem, a squared equals Pythagorean theorem, r equals r squared plus t squared, minus 2, recopy r and t, cosine of angle A. And then we can sub in our numbers. The nice thing about this is in your calculator, you can type this straight in. You don't have to do pieces parts. You can go 10 squared plus 7 squared minus 2 times 10 times 7 cosine of 71 degrees and hit enter. And that gives you a squared. Okay, Friday we'll have, I will come in on Friday. I will put a time there that it'll be close to our normal time. That we will go over just a little bit more of this because we got delayed a little bit today. Okay, so Friday we'll have a little bit of work here. You can start working on the homeworks on the back, Tuesday's assignment. You can start working on that. But I will come in and go over a few of those problems on Friday. Adios. See you on the other side of this. I'll miss you guys. I'd rather be here.
When can I take my half angle quiz?
Well, let's see. Let me see. How about tonight at 7:30 p.m.? Does that work for you? That works for me. How about tonight, tomorrow morning at 5 in the morning? Does that work for you? That works for me. Oh! Now that's a different story. You mean, should we work on your schedule, not my schedule? Okay, then you need to tell me when you're going to be able to come in and do it because I don't know your schedule. Don't want to know your schedule. You need to tell me when you can do it. 5th period you have to do it because 6th period I'm not going to be here.
All right.
See how easy that works? You just tell me I'll be in this time to do it, and I will say fine. I'll be here. Except for I won't be here 6th and 7th period today.
Thank you, Mr.
All right.
Gregory.
Yep. See y'all.
Mr. Gregory,
What?
I won't be in the Google Meet tomorrow or Friday because I had to knee surgery. So I won't be able to be in that.
Oh, it will be screencastified.